Good morning. Today we are discussing about molecular rearrangement reactions. What is molecular rearrangement? In rearrangement reaction, migration of atom or group moves from one atom to another. Mostly migration takes place from one atom to adjacent atom and also it takes place within the molecule. See the reaction. Here A is migrating group. It migrates from A to C. That means A is attached with B. That is migrating origin because A is migrating from B to C. So B is migrating origin. It moved to carbon atom C. So that is migrating terminus. You see the product BCA. Next, coming to classification. Molecular rearrangements are classified based on position of migrating group. Broadly classified into two types. One is intramolecular rearrangement, another one is intermolecular rearrangement. First one we are seeing about intramolecular rearrangement. In intramolecular rearrangement, migration takes place within the molecule. In rearrangement, first the migrating group is detached but it not completely detached from the compound, then moved from one atom to another. Coming to intermolecular rearrangement, in intermolecular rearrangement, migration takes place between the molecule. Here migrating group first detached from the compound, then next step it is reattached to another molecule. So here migration taking place between the molecules. So it is called as intermolecular rearrangement. Next, again molecular rearrangement classified based on migrating group. That means nature of migrating group. It is classified as nucleophilic or anisotropic rearrangement, electrophilic or cationotropic rearrangement. Third one, free radical rearrangement. Further classification, it is classified as aromatic rearrangement, sigmatropic rearrangement. Sigmatropic rearrangement is another class of important pericyclic reactions. We will see in this next video. First, we are discussing about nucleophilic rearrangement. Here, the migrating group migrates without its electron pair. We know electron pair is called electron rich. We are electron rich compound. We are call it as nucleophile or anion. So, this rearrangement is called as nucleophilic or anisotropic rearrangement. Here, the migrating group moves with its electron pair from one atom to adjacent atom. That adjacent atom is mostly it is an electron deficient atom because our migrating group is electron rich atom. So it moves to electron deficient atom. That electron deficient atom may be carbon or nitrogen or oxygen. That migrating group is mostly hydrogen or alkyl group or aryl group. Here also migrating group migrate from one atom to adjacent second carbon. So this rearrangement is also called as 1,2 shift or intramolecular rearrangement. Here the rearrangement proceeds through carbonium ion. So this rearrangement also called as carbonium ion rearrangement. We'll see here we are talking about here nucleophilic rearrangement. In nucleophilic rearrangement, migration takes place from one carbon to another carbon. The deficient carbon may be carbon or nitrogen or oxygen. First, we are seeing about migration from carbon to carbon. You see the reaction. Migrating group R migrates from C1 carbon to C2 carbon. Example for this reaction, phenol-phenolene rearrangement, Wagner-Merwin, benzylic acid rearrangement. Next part, migration of one carbon to adjacent nitrogen atom, electron deficient nitrogen atom. See the reaction, migrating group R group, it's moved from carbon to electron deficient nitrogen atom. Example for this reaction, Smith rearrangement, Beckmann rearrangement, Curtius rearrangement. Similarly, migration from carbon to electron deficient oxygen. Here also migrating group R group migrates from carbon to oxygen. Example for these types, Baeyer-Willis rearrangement, Dakin rearrangement, etc. Coming to next electrophilic rearrangement. Here migrating group migrates without electron pair. That means electron deficient. Electron deficient means it is called it as cation. So it is, this rearrangement is called as cationic rearrangement or electrophilic rearrangement. Here also the migration takes place from one carbon to adjacent atom. So this also called as 1,2 shift or intramolecular rearrangement. Here the rearrangement is initiated by basic reagents. The basic reagents remove the atom or group from our compound. Then it will move to adjacent atom. Here the rearrangement proceeds through carbanion. So this mechanism rearrangement, Fry's rearrangement. Here we are discussing about Niebuhr rearrangement. It is closely related to Beckmann rearrangement. In this rearrangement, the reaction involving the conversion of oxime tosylate to alpha amino ketone in presence of base. In this conversion, azrine is the intermediate. It will be formed in between the reaction. Our substrate tosyl esters, oxime tosyl esters, should have alpha hydrogen. It will undergo reaction in presence of base. Base we are using ethoxide ion or pyridine. Example for this reaction, oxime of acetophenone or acetone, it will convert into corresponding alpha ketone. See the reaction acetophenone oxime, it will react with tosyl group in presence of base. We are using sodium ethoxide. It gives corresponding alpha amino ketone. Similarly, acetone oxime also converted into 1-amine 2-propanone. Here aldoxime, it will not undergo this rearrangement because it should not have alpha hydrogen. Coming to mechanism, we are taking our keto compound. It will react with hydroxylamine. It gives ketoxime. The ketoxime will react with tosyl group in presence of base. We are using pyridine. It gives ketoxime tosylate. That ketoxime tosylate abstract proton and it gives carbanion. Carbanion is intermediate. It will again undergo intramolecular rearrangement, gives the intermediate that is called azridine. Finally, the azrine undergo hydrolysis, yield alpha amino ketone, that is our product in this rearrangement. Best evidence for this mechanism is azrine intermediate, which is isolated and confirmed by Cram and Hatch method. Coming to applications, we have many applications. I will put only 2 applications. Oxime tosylate gives alpha amino ketone. In presence of base, we are using potassium hydroxide. Similarly, N-chloroamine also undergo Niebuhr rearrangement. It gives alpha amino ketone. Thank you.